Hello and welcome to Elimika Dunia's High School Mathematics channel. This will be the first of a series of lessons that we will study under a preparatory unit called Numbers. In this lesson, we will review fractions. As a matter of fact, you have studied enough fractions in the lower secondary school, so we will only go through some important concepts that involve fractions, but which we have observed to confuse many students, including those that are fairly proficient in this subject. The lesson is intended for students in IB's MYP 4 and 5, the Swedish programs grade 9, 10 and 11, as well as the British GCSE Key Stage 4 students. In the case of the IB's MYP 4 and 5 students, these concepts help prepare students for Diploma Mathematics course, both AA and AI, that is analysis and approaches, as well as application and interpretation. Now, before we begin, in case you are viewing us for the first time, please consider subscribing to the channel and liking the video. This way you will always get notified whenever we post any new material. Okay, thank you, and let's begin. Okay. So once again, we are not going to spend so much time on this area on fractions. This is fairly an easy area, but like I have said, there are a few concepts that tend to confuse students, and this includes students that generally find mathematics not that difficult, okay? So what I have in front of me is a notation that we might use to represent a fraction, and this particular fraction is 3 out of 8, or 3 parts in 8, or 3/8 as we normally say. I could represent these fractions using, pictorially. For example, I could use a square, split the square up into 8 equal parts, and then shade 3 parts red, so that I can say that this represents 3 parts out of the 8 parts of the square. Okay, I could also, of course, represent it using a pie chart, and again you can see the pie chart is a circle split up into 8 parts, and 3 parts of those are painted red, and this again would be representing 3 parts out of 8. This is easy stuff, but I think I need to talk about it so that we all know where we are headed. Okay, there are other ways we could represent this fraction here. I could represent it as a decimal, so we know that 3 out of 8 can be represented as a decimal, 0.375. I could represent this as a percentage, and in which case this would be 37.5%. To get that, of course, we would take 3 parts out of 8, 3 parts out of the 8 parts, and multiply by 100%. If we do that on a calculator, you should get 37.5%. Okay. Another way, of course, that you've seen in lower primary school is to use common figures to represent a fraction such as 3 out of 8, such as this one here. This is what you will find mostly in primary school, and so on. Again, we can say 3 fish there out of the 8 are painted red, but the most common way, or the most common form of representation you are likely to meet at this level is going to be a number line like that. So a number line 0 up to 1 that has been split up into 8 equal parts, so that this part here would be 1 part out of 8. From there to that point is 2 parts on 8, and from 0 to that point there would be 3 parts out of 8. So this is another way of representing the same fraction, right? So this is just reminding you about what the fraction is all about, okay? What's the origin of the term fraction, all right? So the term fraction originates from Latin word fractus, which means basically to break a whole. So you have a whole and then you split it up into different pieces. One way to think about that is look at that. So somebody's glass window being broken into small pieces. So if you have one whole piece, in this case, one whole piece of glass covering that window, and if it splinters into those different parts would be fractions of the whole glass that was initially the window, right? And we can use this image here and compare with what is happening to my circle there. So the circle could splinter into 2 parts so that each part is a half, like that, or into 7 parts so that each part is 1 out of 7, or into 3 parts so that each part is a third, and so on, right? So the splitting up of a whole gives us a fraction, a part of a whole, okay? Good. Now let's see parts of a fraction. Again, this is something we are familiar with. So when we represent a fraction like this, the denominator of the fraction tells us how many equal pieces of the whole that the whole is divided into. So we have a whole, which was that full circle there, and we've split it up into 4 parts. So therefore, the denominator there, or this one here, tells us how many parts we've split up the whole into. Okay, like that. So that denominator there, as well as the other one there, is indicating that if we have one whole, then we've split it up into 4 parts. Okay, if it was a third, then it would mean we are taking the whole and splitting up into 3 parts. Okay, the numerator tells us how many pieces of the whole the fraction represents. So when we write 1 out of 4, we mean that the fraction represents just one part, so this part here that has been pulled out, one part of the 4 parts of the whole, all right? Similarly, the 3 there represents 3 parts of the 4 parts. So 3/4 there means that we are taking 3 parts of the 4 and dividing into 4, like that. So this is again not something that is difficult, and so we can move on and see what we get next there. All right. Okay, so that is what the numerator tells us about the fraction that we have. Let's look at some definition and some types of fraction. So how do we define a fraction? A fraction can be defined as the ratio of integers. Okay, so a fraction is a ratio of integers. A ratio, we know what that means, but before I go there, let's look at integers. We will see in another unit that integers refers to complete numbers. I don't want to use the term whole numbers because that also has a different meaning. So integers refers to complete numbers, whether it is positive or negative. So here are examples of complete numbers. The dotted line there implies that this continues to infinity, and this side also continues to infinity. So complete numbers, whether it is positive or negative, are referred to as integers, and the set symbol for numbers that fall under integers is this Z with 2 lines at the center, as you can see there. So a ratio of 2 of these integers is referred to as a fraction, provided that 0 is not one of those fractions. Okay, it's not one of those integers. Okay, so a ratio, we will already know A is to B is ratio of A to B, which can also be expressed as A over B. And when we express it this way, we refer to it as a fraction. So a fraction is a ratio of integers A and B, where A and B must not be 0. In fact, A could be 0, in which case the fraction would be equal to 0, but B can never be equal to 0. So a ratio of integers, A is to B, where B is not 0, and A and B are integers. Here is an example of a fraction. All right. So the 5 is the numerator, there is a line in between and a denominator like that. We'll go quickly, this is boring. All right. There are types of fractions, and here we are concentrating on the terminology, the terms that we use to represent, to refer to fractions. This is now important. Okay. Now, so for a fraction that we have represented by A over B, where A and B are integers and B is not 0, if A is less than B. Now the 2 lines there mean that you ignore negative. So if we have, for example, so if we had, for example, -4 over 3, then we are going to ignore a negative sign. So where there is a negative sign, you ignore it. So that the two lines you see there for A and for B means ignore the negative. So we can see in this case 4, which represents A, is bigger than 3. All right, and in a fraction such as this, 2 over 3, we can see that the value of A, the numerator, is smaller than the denominator. Okay, and so if the numerator is smaller than the denominator, as we see here, then this fraction is referred to as a proper fraction. So whenever you have a fraction in which the numerator is a number that is smaller than the denominator, you ignoring the negative signs if they appear, then such a fraction would be referred to as a proper fraction. All right, so these are important for us to remember. You already remember this, but just in case, this is the reason why we are going through this. So if A is a number that is smaller than B, then we have a proper fraction. Okay, here is an example of a proper fraction. You can see 3 is the number in the numerator, which is 3, is smaller than the number in the denominator, which is 7. So this is an example of a proper fraction. On the other hand, if the number in the numerator is larger than the number in the denominator, then what we end up with is what we refer to as an improper fraction. So these terms are terms that I want you to remember as we move forward. Okay, an example of an improper fraction is 8 out of 5. So you can see that the numerator is now larger than the denominator. Okay, all right. An improper fraction, the one we've just seen, 8 out of 5, an improper fraction may be expressed as a combination of a whole number and a proper fraction. In that case, we would refer to it as a mixed fraction. For example, if we write 2 and 2 over 5 like that, so this is a natural number, a whole number, together with a fraction. Normally when we write this, students tend to think that this means there is a multiplication sign between the 2 and 2 over 5. The reality is that that is actually a plus, as we will see shortly. So when we write 2 and 2 over 5, that means 2 plus 2 over 5. This is called a mixed fraction, and we can produce a mixed fraction from an improper fraction, as we will see shortly. Okay? Other examples of mixed fraction. So 4 over 3 can of course be expressed as 1 and a third. I'm hoping that we are okay with this, but in case you are not, all you're doing is you're dividing really. You're saying put the 3 outside and the 4 there. 3 goes into 4 1 times to give us 3, and then we subtract and there is a remainder of 1. So we'll say that our answer 4 over 3 becomes 1, this one here, okay, and 1, this one, the remainder here, out of 3 parts. So 4 over 3 can then be expressed as 1 and a third. I'm hoping that you know how to do this, but in case you don't hesitate to ask me. Write a comment in the comment section, or if you're a student that you can ask me directly, I will be able to respond to your question. Okay, you can send me a message, I will be able to respond to it. Okay, so that's another example of an improper fraction being converted into a mixed fraction. Each student, each of you should be able to convert a mixed fraction into an improper fraction into a mixed fraction, and vice versa. Okay, another example perhaps is 15 out of 7. Now 7 goes into 15 twice to give us 14. So we would write this as 7 going there twice. So we'll write 2 as the integer. There is a remainder of 1. So it will be 1 out of 7. So we can express 15 over 7 as 2 and 1 over 7, like that. Okay, so that is a mixed fraction. Is there another one? Yes, 6 out of 5. 5 goes into 6 once, and there is a remainder of 1. and therefore we can express 6 over 5 as 1 and 1 over 5. This should not be difficult at all, but once again, in case you find this challenging, let me know and we can go through it together. Okay, we are still looking at types of fraction. Fractions with the same denominator are called like fractions. Okay, if the denominators are not the same, then they are unlike fractions. So you need to know that if fractions share the same denominator, like a third and 2/3, so if the denominator is the same for two fractions, we refer to them as like fractions. We always want our fractions to be like before we add them or subtract them. But we are going there right now. All right, example, 3 over 4 and 1 over 4 are like fractions because the denominators are the same. If the denominators are the same, we refer to those fractions as being like. Okay, so these are like fractions. Similarly, 1 and 1 over 5, if you remember, that was 6 over 5, right? 5 times 1 is 5 plus 1 is 6, so 6 over 5. So 6 over 5 is one fraction. Another fraction there is 2 over 5. And once again, 6 over 5 and 2 over 5 share the same denominator, and therefore these are also like fractions. Okay? What about this? 1 over 5 and 5 over 8 do not share the same denominator. So the denominator here is 5, the denominator there is 8. So these are not like fractions. We say they are unlike fractions. Okay? If you need to add or subtract like fractions, then the addition is pretty straightforward. They will keep their denominator. So this will become 3 plus 1. Whatever you get, divide by the common denominator. This would be 6 plus 2, which is 8, divide by 5 when you add them. Okay, if you subtract, it would be 6 minus 2, which is 4, divide by 5. So 4 over 5. But when the two fractions are unlike like that, then it is not straightforward adding them or subtracting them. And so you're going to have to take them through a process to ensure that the denominators are the same, and we are going to look at that shortly. Okay, so but I'm going to write that there, that before adding or subtracting fractions, we must first ensure that they are like. Okay? Okay, we're still on types of fractions and the terminology that we use. Okay, fractions with the same value when reduced or when simplified are said to be equivalent fractions. All right? If the values of the fractions are the same, where if you turn the fractions into decimals and the value of the decimal numbers are the same, then those two fractions are said to be equivalent. Here is an example, 1 over 4 and 3 over 12. Now 1 over 4 is really 0.25, but so is 3 over 4. On the other hand, we can also choose to reduce this because we are going to see how we do this reduction. So this is 1 over 4, but 3 over 4 can be expressed as 3 divided by, not 4, but divided by 12, can be expressed as 3 over 3 times 4. Okay, and so we can write this as this goes here once and that goes here once, and we have 1 over 1 times 4 is 1 over 4. So you can see 3 out of 12 is the same thing as 1 over 4, like that. 1 over 4 and 3 over 12 are referred to, I know all of us can do this, but some may not remember what the name is. Being, if we're coming from an international field, it means different people use different languages, and maybe you do not use this word equivalent fractions. So now you know that fractions that have the same value when reduced or when simplified. So to reduce is to simplify, to do what I've just done here. So when we reduce them like that and they end up being the same fraction, we refer to 1 over 4 and 3 over 12 as equivalent fractions. So 1 over 4 is equivalent to 3 over 12, which is also equivalent, I believe, to 6 out of 24, and so on. Okay, so those two are equivalent fractions, and if you look for their values, it's going to be 0.25. Okay, a half and 25 out of 50 are also equivalent fractions. I can write 25 on 50 as 5 times 5, so 25 is 5 times 5, and 50 is 5 times 10, okay, which is the same as 5 times 5 over 5 times 5 times 2. So that 5 goes with that, 1 and 1. This goes with that, 1 and 1. 1 times 1 is 1. 1 times 1 times 2 is 2. And so we have reduced 25 out of 50 to 1 over 2. So that process shows us that a half is the same as 25 out of 50, or is equivalent to 25 out of 50, like that. If you find this too easy and so a bit boring, you can always forward. But we have to do this for the sake of the other students who are preparing for analysis and approaches, as well as application and interpretation course, especially those who may not have done this in school and have to start from scratch. Okay? All right, so once again, a half and 25 on 50 are called equivalent fractions, because when you reduce 25 out of 50, if you reduce it or if you simplify it, it turns out to be the same thing as a half. Okay? All right, and if changed into decimal, both of them are going to be 0.5. So these are examples of equivalent fractions. Okay? What about 2/3 and 16 on 24? All right, 16 on 24, we can see 8 goes into 16 twice and goes into 24 3 times. So again, 2/3 and 16 on 24 are equivalent fractions. Okay? Right. When we turn that into decimal, we get a recurring decimal such as what you see there. Recurring decimal means 0.66 and it continues to infinity, so we say it is a non-terminating recurring decimal. Okay? Right. Let's move on. We must always reduce our final answers to the lowest equivalent form. So if you are working with some fractions and you end up with an answer of 16 on 24, please don't leave it like that. We always reduce it to the lowest possible form, which in this case would be 2 out of 3. Okay, let's move on. Some fraction facts, and this is the unity fraction. I've actually used the unity fraction already in the examples we've looked at, but let's now officially look at it. Adding all pieces gives the whole. So for example, here is a pie chart with pieces that are different sizes. Okay, so we have 1 out of 60. So this piece here, the purple piece there, is 1 part in 60. All right, there is one there that is another one. There is 27 on 60. There is the yellow one, which is also 1 part on 60, and so on. So when we add all the parts of that whole pie there, we should be able to get the full, which is to say that if we add 1 over 6 plus 1 over 60 plus 1 over 60, if we add all of them together like that, we should be able to get 60 out of 60, and 60 divided by 60 is the whole, which is 1. Okay? What am I leading to? Looks very obvious. We are trying to say, if we say 60 out of 60 is the same as 1, it implies that any number divided by itself is always equal to 1. We know this, but it's important that we say this here for the sake of those who may not have thought about it, which means a divided by a is 1. N divided by n is 1. X divided by x is always equal to 1, like that. So this is a point of note that I want you to remember. It's a fraction fact that a divided by a equals 1, and we can see that in the example that we've looked at. Okay? All right, another fraction fact. A fraction with a denominator of 1 is equal to its numerator. So 20 divided by 1 is 20. 5 divided by 1 is 5. So a fraction with a denominator of 1 is always equal to the numerator. Okay, for example, a divided by 1 is the same thing as a. Alright, why am I going through these things? Because experience has shown us that there are students who are struggling with this. So if you find this is easy, don't worry, just move on to the next, you can forward. But those who are seeing this for the first time, this is going to be helpful in manipulating fractions. So keep up with the video. Alright, let's move on. Another fact, division by 0 is undefined. In other words, we cannot divide a number by 0. So the denominator of a fraction cannot be equal to 0. I said this right at the beginning when I defined fraction, right? So the value of b, if a fraction is given by a over b, then the value of b cannot be equal to 0. The denominator can never be equal to 0. If we make the denominator 0, the fraction becomes undefined. Okay? There is the fact that a fraction can be expressed as a over b, where b must never be equal to 0, like that. Okay? Based on those 3 points that we've looked at, it follows that, and this is now the fundamental property of fractions, okay, that if you are given a over c divided by b over c, then I can split that up so that I have c over c. So I'll have a over b, and I can split that up and I have multiplied by c over c, like that. But we've seen that a number divided by itself is 1. So I can replace c over c with 1, like that. And so the answer becomes a over b. Alright, so we need to be able to see that this basically reduces to a over b, because c cancels the c there to give us 1. Okay, this is important. This is a problem I've seen with many students joining us from the Swedish program, but also some of our own students sometimes face these challenges. Okay, we use this fact to reduce or to simplify fractions to the lowest point. You saw us do that when we reduced, I think it was 16 on 24, and I think there were 2 others that we reduced to the lowest form. Okay, so this is the best method that we use to reduce them. For example, let me just do that again here, so that I remind you of what we've done. If we are given 16 on 24, I can express this as 2 times 8, and I can express 24 as 3 times 8, and now I have 8 over 8 just like c over c there, so this will cancel with that to give me 1 over 1, which is 1, and my answer is 2 over 3, like that. Okay, so this idea is what we use when we want to reduce fractions to their lowest form, okay, to their lowest equivalent form. Right, let's move on. Here's another example. So 4 over 10 can be expressed as 4 is 2 times 2 and 10 is 2 times 5. So you can see we end up with a 2 and a 2. I can cancel those 2. By the way, I can cancel that and that as well. It doesn't matter which one is in front and which one is behind. And so what I'm left with there, if I cancel like that, and the other one, that is 1 over 1, and I'm left with 2 over 5. Okay? So that's a process of reduction or simplification to the lowest equivalent form. Okay? What about the idea of equality of fractions? Okay? So we say, if a over b, if some fraction a, if we are told some fraction a over b is equal to another fraction c over d, then we can use something called cross multiplication, which is to say we can multiply a and d and keep on one side, and multiply b and c on the other side. So we call it cross multiplication because we are multiplying like this, because c is multiplying C there, this C here is multiplying B, and this A is multiplying D, so we kind of end up with a cross, and we refer to that as we are doing cross multiplication. Okay, so that's why we refer to this as being cross multiply. And so A over B, if A over B equals C over D, then A multiplied by D must be equal to B multiplied by C. This is a very important tool when we are solving equations in which there is one unknown, one or more unknown. It's always helpful to do what we call cross multiplication. I think I have an example. So we use cross multiplication when solving for an unknown in the numerator or in the denominator of one of those fractions. Here is an example. Solve for x, and I have there x over 10 is equal to 2 over 5. So if those two fractions are equal, then we can cross multiply. So I will write 5 multiplied by x, which gives me 5x, must be equal to 10 multiplied by 2, which is 20. So 5x must be equal to 20. And when we reach this scenario, MYP5, MYP4 students, you'll already know we need to divide both sides by 5. If we do that, then we are left with x being equal to 4, like that. So the idea of cross multiplication is useful when we are solving for an unknown. Okay, sometimes also when we are making one of them subject of the formula, then cross multiplication also becomes useful. All right, now we go to operation with fractions, and we start with addition and subtraction. Adding or subtracting fractions is often more difficult or involves more steps than multiplying or dividing. So when we are adding or subtracting, we need to ensure that the fractions are like. Okay, so the fractions must be of the like type in order for us to add them or divide them, which is to say we must ensure that the denominators are the same before we attempt to add or subtract them. Okay, for example, so if we have a fraction A over B and we want to add or we want to subtract another fraction C over B, then this is easy because these two fractions are like. Their denominators are the same, and therefore they are like fractions. And so all we have to do is add A and C and divide by that common denominator there, right? So we are either going to have A plus B, or we're going to have A minus B, and then we divide by, this is supposed to be C, isn't it? So it is A plus or minus C. This is supposed to be C here, sorry. Okay, so that there is a C. So A plus or minus C divided by that common denominator there. So if we're going to add fractions, we must ensure that they are like fractions. If they are like, such as these ones, then the addition or subtraction is straightforward. However, if the two fractions are not like, well, let's look at an example here. We have 2 over 5 plus 1 over 5. All you have to do is take 2, add 5, and divide by the common denominator there, which is 5. So we end up with 3 over 5, and that is the sum of the two fractions. Okay? On the other hand, if the two fractions are not like, the two fractions we want to add are unlike, then the first thing we have to do is use the idea of unity A over A to ensure that the two fractions are like. Okay? So to add or subtract unlike fractions, okay, multiply one or both fractions by another fraction that is the equivalent of 1 to create a common denominator. Like this, sometimes understanding that is difficult, so we just look at an example. So to do that, here we go. So A over B plus or minus C over D. So now you can see the denominator is B and D. These are not like fractions. So what we need to do is to ensure that the fractions are like, and this is how we go about it. All right? So we ensure, so because this is B, we want to involve a D there, so we multiply by D over D. So we take A over B, multiply by D over D, and take C over D and multiply by B over B, like that. So when we multiply and divide like that, we end up with like fractions, because now the denominator of this is going to be BD, the same as the denominator of this going to be BD. And so our answer is going to be, the denominator will be BD, and so we have AD plus or minus CB, like that. Okay? I hope this is making sense. Most people have done this, of course. You are now used to doing this. There is a fast way of doing this, of course, which is just there, without having to take it through this process. Here we can write the solution in one step. I'm going to show that now. So we have 3 over 2 plus 2 over 3. Now if we want to add this together or subtract them, all we need to do really is just say, so from here we can just say 3 times 3, so 3 times 3 there is 9, and plus or minus, that's this one here, and then we have 2 times 2 there, which is 4, and everything divide by 2 times 3, which is 6. Alright, so this is the same thing as what you have done there, and that's how you will add or subtract fractions in one step without having to go through this process there. We'll look at another one later. Okay? Okay, so going through the long process, for the first fraction we multiply by 3 over 3, but for the second fraction we multiply by this 2 over 2, like that, and that gives me directly what I wrote in one step, which I get. The 9 is found by taking 3 multiplying by that 3, the 4 is found by taking the 2 here multiplying by the 2, and the 6 is found by multiplying the denominators together. So that's a quick way of adding or subtracting fractions. Please try it out. What about multiplication and division? So multiplying or dividing fractions is much faster, does not require all the complications of addition and subtraction. So you just multiply the numerators together and the denominators together in the case of multiplication, like this. So A over B multiplied by C over D is simply AC. That is A times C, multiply the numerators together and multiply the denominators together, which is B times D. Okay, here is the example. For multiplication, 3 over 2 multiplied by 2 over 3 is going multiplied by 3 over 4. So now I have 3 fractions. All I have to do is to multiply all of them. But before we do that, we must always try to ensure that it is as simple as possible. So here, for example, I don't need to say 3 times 2 times 3 and 2 times 3 times 4. Why? Because I can see there is a 3 in the numerator and a 3 in the denominator. So I can actually cancel those two, 1 and 1, using the unity law. And I can also see a 2 there and a 2 there. So I can also cancel these two, and I'm left with 3 over 4. So by just inspection, I can see that that product of fractions ends up being just 3 out of 4, like this. Okay, reduce before multiplying, and so 2 goes with that 2, that disappears as 1, and the 3 also disappears with the 3 there, and so I'm left with 3 over 4 as my answer, or as the product of those 3 fractions. So it is pretty straightforward multiplying fractions. Okay, to divide fractions, we must first flip the divisor, that is the one in the denominator. Okay, and then we can multiply just like before. Here is what I'm talking about. Many students do not know how to do this. So suppose we are given A over B and we want to divide that by C over D. So then the first thing you need to do is to flip the second. This is the denominator. So by the way, this expression here, I could also have written it as A over B divided by C over D, like that. So the division, this line here is the division sign. which is to say C over D is the divisor because it is in the denominator, okay? So when you meet a question such as this one, what you want to do is express it in this form. So we want to express this as A over B and replace this line with the division sign, okay, and write C over D. And then what we want to do is to flip the divisor. Remember, this is the divisor, the one in the denominator. Flip it like that. So now I have A over B, and flip this to D over C. But if you flip that, the sign, the division sign, changes and becomes a multiplication sign. So the reason you are flipping is so that you turn this into a multiplication sign, and once you've done that, then you just multiply the same way that we did that multiplication. And so this is A times D divided by B times C, like that. Okay? Once again, if this is moving a little too fast, you can always slow down the video, but again you can also ask me questions so I can go through the problems with you, or go through the concept a little slower than we are doing now if you find this too fast. Okay, so let's see that. This is what I've just done. So that is the divisor. We want to flip that. So if we flip it, so C goes down and D goes up, the sign changes from that of division to that of multiplication. And now all we have to do is to multiply the numerators together and the denominators together. We end up with AD over BC. Okay, straightforward, very simple. Here's an example for division. We have 3 over 2 divided by 3 over 8. So of course the first thing we're going to do is to flip the 3 over 8, which is the divisor. 8 goes up, 3 goes down, okay, and 8 now has gone up, 3 has gone down, and now we can multiply 3 and 8 and 2 and 3. But once again, by just quick inspection, you can see there is a 3 down here and there is a 3 up there. So before I multiply, which just gives me larger numbers, I can reduce that and just cancel. Remember to reduce before multiplying. And so 3 there goes with, you can see 8 can also be expressed as 2 times 4. And so 2 and 2 can cancel. And 3 and the other 3 can also cancel. And we are left with 4. Of course, you can do it your own way. 3 times 8 is just 24, and 2 times 3 is 6. 24 divided by 6 is, of course, equal to 4. So, of course, you don't have to do it exactly the way I have done it, but what we are saying is when the numbers are very large, then sometimes it's better to reduce first before you do the multiplication, okay? Makes your life a little bit easier. Right. Next, mixed fraction. Mixed versus improper fraction. We can convert mixed fraction to improper fractions and improper fractions into mixed fractions. Let's see. All right, so A and B over C, this is not, so when we express a mixed fraction like this, please remember this is not a multiplication sign in between there, it is actually an addition. So it means this, okay? This is the one thing that again confuses many students. Remember, A and B over C as a mixed fraction or as a mixed number means A plus B over C. Okay? It is often useful to convert mixed fractions into improper fractions before performing calculation. So if in the calculation one number is given as a mixed fraction, always try to convert it into improper fraction. Okay? It is easier to perform mathematical processes with fractions than with decimal numbers. So please avoid converting a fraction into a decimal number before conducting or performing calculation. Okay? All right. So to do this, we change the whole number to an equivalent fraction with the same denominator as the other fraction. Let me just show this with an example so you understand what's going on here. So here is an example. So we have 2 and 3 over 4. So this is a mixed fraction. Now, we know if the denominator is 4, then we want to express this 2 as an improper fraction with a denominator of 4. So there is a number over 4 that is equal to 2. So 2 is the same thing as something over 4. So obviously the number that is here has to be 8. And remembering that in between here is an addition and not a multiplication sign, now we can write that. So 2 and 3 over 4 can now be expressed as 2 plus 3 over 4, which is the same as 8 over 4 plus 3 over 4, and that gives me 11 over 4. So now it becomes easy to add them. So I've converted my mixed number or mixed fraction into an improper fraction. This is how you convert from mixed fraction to an improper fraction. Of course, a faster way is to just say 4 times 2, then plus 3. So 4 times 2 is 8, plus 3 is 11. Whatever you get, you divide by 4. Okay? Let's see that. I think this did not come out well. So this is 8 over 4 there, and this is 3 over 4, and this equals to 11 over 4 there. Okay? Sorry that it's not appearing clearly. But let's see a cleaner version of it. So 2 and 3 over 4 can be expressed as 2 plus 3 over 4, but the 2 can be expressed as 8 over 4. And so when we add that, we get 11 over 4, like that. Okay? This is a bit too quick, or too slow. We should be able to find this without really having to do this by just saying 4 times 2, which is 8, plus 3, which is 11, 11 over 4, like that. Okay? A more versatile or rapid way to convert a mixed fraction to improper fraction is just what I've just said. That is, so if we have this, we say C times A, so that is AC plus B. So we multiply those two, then we add B, and everything we get we divide by C. Okay, so write it as AC plus B over C. Okay, here's an example. So if we have 2 and 3 over 4, then we just say 4 times 2, which is 8, plus 3, which is 11, and 11 we divide by that denominator, which is 4. Okay, like that. It's a quick way of converting a mixed fraction into an improper fraction. Right. What else is left? Now here are some questions for you to try out. So what you will want to do is to just pause the video and try them out. Convert the following mixed fractions into improper fractions. All right. So here is 1 and 1 over 4. Here's another one, 7 and a half. 3 and 2 over 5. Okay, that's the answer to that. So pause the video and solve them, and then check these answers to see if you've got them right. So this one gives us that as the answer. Try the other one. Please pause the video and try them. Okay, if you've done so, then the answer to the second one, you should be able to see it is 15 over 2. And the answer to the third one is, this is 5 times 3, which is 15, plus 2 is 17. So 17 over 5. Our answer is 17 over 5, like that. Okay, try them out before you see my answers, of course. Mixed versus improper fraction. To go from, so we've seen how to come from mixed fraction to improper fraction. Now to do the opposite, to go from improper fraction to mixed fraction, we divide the numerator by the denominator, and the remainder is placed over the divisor, like this. Okay, so a number n which is bigger than d for it to be an improper fraction. So first of all, we see how many times d goes into n. All right, and we will write that down, and whatever remains is what we place under d. So that would be, for example, q. So D would be going into N Q number of times, and then we say plus some remainder over D. Let's look at an example of that with that still there. So 11 over 4, we say 4 goes into 11, 3 times would be 12, so it has to be 2 times to give us 8. So 4 goes into 11 twice to give us 8. So we write 2 here, so it goes twice to give us 8, so we've not reached 11. There is a remainder of 3, and that 3 is what we place over 4, like that. Okay, let's move on. Now we want to compare fractions. All right, comparing like fractions. How do we compare? How do we tell? To compare means we want to know which one is bigger than the other. So if you're given 2 fractions and you want to compare them, how exactly do we do that? So like fractions are very easy to compare, like because their denominators are the same. So if the denominators are the same, then we just look at their numerators, and the bigger numerator tells us the bigger fraction. So like this. Okay, like fractions have a common denominator. That's just to remind you of what we've done a few minutes earlier. Okay, and so here's an example. So given 4 over 7 and 2 over 7, which one is bigger? All right, so the denominators are the same, so these are like fractions. All we need to do is look at the numerators, and we can see 4 is greater than 2, and for that reason 4 over 7 is greater than 2 over 7. So if the fractions are like, then comparing them becomes very, very easy. Okay, it is clear that 4 over 7 is greater than 2 over 7 because the numerator 4 is greater than the numerator 2 there. Okay? Now, comparing unlike fractions. So if they are not unlike, if they are not like, in other words, they are unlike fractions, our first task is to liken them. In other words, do something to ensure that their denominators are the same. All right? So how do we do that? Here is an example. We are given 4 over 7 on one hand, and the other fraction is 2 over 3. So clearly now these 2 fractions are unlike. How do we find out which fraction is bigger? To do that, we need to ensure that the fractions are like. So we will put them down, 4 over 7 and versus 2 over 3. What we want to do is look at the denominators. So the denominator here is 3, so I'll go here and multiply by 3 over 3. So that becomes 12 over 21. So multiply by 3 over 3. And this one we multiply by 7. So 7 over 7 on this side. That ensures that the denominators are 7 times 3, which is 21. So now we have 12 over 21 and 14 over 21. Okay, and so clearly the numerator there is bigger than the numerator there, and that tells me that 2/3 is greater than 4 on 7. Okay, so this is one way to ensure or to compare a number of fractions. Okay, 4 over 7 is less than 2 over 3. 2 over 3 is greater than 4 over 7 as another way of saying it. We have compared the 2 fractions. Okay. Of course, an alternative way is to express the 2 fractions as decimal numbers. Okay, if we convert them to decimal, 4 over 7, I believe, is what, 0 point what? 4 over 7 can be expressed as 0.5714, and it continues. We don't need all the decimal places, just the first few. Okay, sometimes just 2 decimal places is enough. 2 over 3 is a recurring decimal, 0.6666. And so you can see by looking at the decimals that 2 over 3 as a decimal is greater than 4 over 7. So this is a second way of comparing fractions. Okay? Right. Let's move on. What about algebraic simplification? Algebraic fractions. So what is an algebraic fraction, first of all? So fractional expressions that contains unknown. So instead of 1 over 3, if I have x over 3, or a half x or a half a. So if a fraction contains an unknown such as x, a, b, y, t, and so on, then we refer to it as an algebraic fraction. An algebraic fraction is a fraction that contains an unknown either in the numerator or in the denominator or on the side and so on. Here are some examples. I believe I have them here. So a half x, which can also be expressed as x over 2, that is an algebraic fraction. Okay? 3t over 5 is an algebraic fraction. 4 divided by 1 plus y is an algebraic fraction. Okay? A plus 1 over 3 is an algebraic fraction. So these are some examples of what we refer to as algebraic fractions. All right? Fractions that contain unknowns. All right, now let's move on. The addition, subtraction, and multiplication, as well as division of algebraic fraction, follow the same rules that we use with normal fractions. Okay? And what do we mean? That if we wanted to add two fractions, so 4x over 5 is an algebraic fraction, and if we wanted to add that to x over 3, which is another algebraic fraction. So this is simplification of an algebraic fraction. Can we combine them so that they are under one denominator? And the answer is yes. Now, of course, these are unlike fractions because the denominators are not the same. So the first task usually is to ensure that the denominators are the same. That is by multiplying this by 3 over 3 and multiplying that by 5 over 5, like so. Okay, we will move that slightly, and so the first one will multiply by 3 over 3 and the second one will multiply by 5 over 5 as we've learned before. And so now I have 12x. 4 times 3 is 12x. Okay, and this becomes 5x, right? So 12x plus 5x is 17x. And this is 15, and that is 15. So the common denominator is 15. So I have 17x over 15, like that. Okay, let's see that. Okay, and I have the answer to that sum of algebraic fractions as being 17x divided by 15. Okay, so the same, you can see that the same rule we used with the regular fraction is what we use with algebraic fractions as well. Okay, this is now really important at this level. We've left the primary school fractions. Now we are getting into the real deal that is important to you as a student. Another example, simplify this. This time we want to add and look at how those two fractions look like. Again, you can see the denominators are not like. So these are unlike fractions. The denominator here is y plus 1, that is y plus 2. So they are unlike fractions. The first thing we do is to make them like fractions. Okay? How do we do that? We will multiply the first one there with the multiply and divide by the denominator of the second one. In other words, here we're going to multiply and divide by y plus 2, this one. And this one will multiply and divide by y plus 1, like so. Okay, separate them slightly. And so I'm going to say multiply and divide by the denominator of the second fraction. As for this one here, multiply and divide by the denominator of the first fraction there, like that. Okay, and then all we have to do is to simplify. 4 multiplies y, that is 4y plus 8. And this is 3y. Okay, and this is going to be plus 3. It will turn out to be minus. Okay, but it doesn't matter right now. So what do we get then? So 4 into y plus 2 minus, this minus here, 3 into y plus 1, right there. And then we divide by one of those common denominators, which is y1. Y plus 1 into y plus 2, like that. And we could leave the answer like that, although the numerator is better simplified further. And that gives me, open the bracket. You've learned how to open that bracket. I'm hoping that is not a big deal. So I'm left with y plus 5 So 4y here minus 3y is y, and 8 minus 3 is 5. So the numerator remains y plus 5, and the denominator remains those two fractions like that. So I can express my answer as, why am I getting, that cannot be 4 because this is y. That cannot be the answer. Oh, okay. So that gives me y plus 5 over that, and that is my answer to, we have simplified the algebraic fractions. Okay? Go through this slowly and see that you see the process clearly. You will need to be able to do this again and again and again. So it's a good idea for you to know how to do it. All right. Here's another example. Simplify 3 over mn multiplied by m minus 1 over 2. So this is no longer addition or subtraction, it's now multiplication. So we use the same rule that we use for multiplication of fractions. Okay, try it out. You can pause the video and try the question out before continuing to see the solution. Okay, so what we do here is just multiply the numerators and multiply the denominators like this. Okay, so that becomes 3 into m minus 1 divided by 2 times m times n. Notice that when we write this, the number comes first and the letters are also expressed in the order that they are in the alphabet. Okay? We can leave our answer like that, and if you like, you can open the numerator and you have 3m minus 3. It doesn't really matter. This is already a good answer as it is. Okay? Okay, so that becomes the solution to the problem. Right. Here's another example. This time it is 8 over t plus 2, and we are dividing by 1 over 2t plus 4. Now in division we said we flip the divisor. So the second fraction there is the divisor. So we need to flip it up. So if we flip that up, there we go. We end up with the 2t plus 4 going to the numerator and 1 going to the denominator. And then we just multiply as normal. So we have 8 into 2t plus 4. Everything over 1 into t plus 2, which is just t plus 2. And you can simplify that if you want. We end up with, what is that? We end up with 16 into t, so you can say I've moved the 2 out from here. If we move the 2 out, we end up with 8 times 2, and now I have t plus 2 and t plus 2 in the denominator, and so I can cancel the 2, and I end up with just 16. Okay, so the solution to this problem here, if you simplify that problem there, you end up with just 16. Yes? Okay, additional questions on this can be found on the e-workbook that I will share as a link in the comment section below. So check it out to see the e-workbook for this kind of questions. Try those questions out and let me know if you face any difficulty. I will take you through the solution. Okay? Later in the course of the year, we will also post the solution set to that worksheet or that e-workbook. All right, so here's another one. To remove fractions from an equation and make it easier to work with, we multiply each term with the LCM of the denominator. So this is what I'm talking about here. If you're told to solve a question such as that, it is solved, so it is equal to a half. If we're going to solve this problem, you can go through the long method of adding those two fractions together, multiplying by 3 over 3 and 5 over 5 there and so on. But the alternative is to look at the denominators of the fraction. We can get rid of the fractions, okay? So the denominators are 5, 3, and 2. The LCM of those denominators is, from there you can see it is 30. All right, so the LCM is going to be 30. Okay, and so all we have to do, so find the LCM of the denominators and then multiply each of the terms. So there are 3 terms here. This is one term here, this is one term, that's another term, and that's another term. So multiply each of the terms by 30, the LCM of the denominator, and see what we get. So this is a trick that some students do not know. If you don't, please find this, you should find this useful. So we are going to multiply each of the terms with that LCM. Okay, multiply by 30, multiply by 30, and multiply by 30. And now we can cancel some. 5 goes here once, it goes there 6. Okay, so I can cancel 5, there goes once. 5 goes into 36 times. All right, which is to say that the whole of this is now just 12x. Okay, and similarly 3 goes here once and 3 goes there 10 times. Okay, and so this becomes 10 into x plus 2, and this is just 15 because 2 goes there 15, 15 times 1 is 15. So we end up with, let me simplify that. Okay, and so what do we end up with? 12x from the first term. This becomes 10 into x plus 2, which is the same as 10x plus 20, and that is equal to 15. And so I can rearrange. This gives me 22, and 20 goes to the other side and becomes negative 5. I hope this is not a big deal. You're okay with it. So we end up with negative 5 on the right hand side, and so x is equal to, divide both sides by 22, and the value of x is negative 5 over 22. So we have solved an algebraic equation such as that one there. It's basically a linear equation, but in algebraic fraction form. Okay, again, there are questions in the E workbook. Take a look at them and try to solve them. All right. We will stop the lesson here and we will continue with the remaining part shortly. Okay? Thank you very much. See you in the next section. So welcome back, and let's see some examples on this. Okay. I want you to try these questions. It should take you a few minutes at most. Here is one question. Question A. The first thing is to simplify the equation. Simplify it the way we did by multiplying through by the LCM of the denominators, and then solve the equation where possible. Okay. So pause the video and try out this question. All right. The next question, which is B. Again, simplify the following equation. All right, here all you have to do is to simplify. Okay, I believe I have another one. C says simplify the following equations. Equation A is given there, and there is an equation B. Please try and simplify that. This is supposed to be divide by, so this has kind of moved. So it's 3 into x plus 1 over 8. Divide by 5 into x plus 1 over 16. Okay, try to solve that. This is divide, just same as that there. What about the previous one is subtract, so that is just simplifying. So try those ones out. Divide. Okay, pause the video, try them out. I think there's a D. Simplify and solve the equations shown. Okay. We can look at the solutions later, but first I would like you to try them out. If you get confused, just go back and see our solution of the previous example. It should not be that difficult. Okay? The next bit is going to be to change numbers from decimals into fractions and vice versa, fractions to decimals. See you in the next video.